In this video, we are going to look at two questions on projectile motion. This is question 1. Pause the video now and try the question. In part A, we are asked to find the time it takes to reach the ground. So as always, we should draw a diagram. Now, this is obviously a very simple diagram, but it still helps us be clear what is going on. So the object is projected horizontally at 8 meters per second, and the height of the cliff is 30 meters. And we're asked to find the time it takes to reach the ground. So what do we need to do? Well, we need to realize that the y motion and the x motion, these are independent of each other. So they don't affect each other. So its horizontal motion has no impact on the vertical motion. So vertically, what is going on? Well, let's list our variables. The displacement is going to be 30 meters. The initial velocity vertically, this is important, vertically here is 0. The final velocity we don't know, but we actually don't need to know at the moment. The acceleration is due to gravity, so that's 9.8 meters per second squared. And t is what we're being asked to find. So what equation has s, u, a, and t in? Well, we're going to be looking at this equation, ut plus half at squared. And importantly, u is 0, so this bit here equals 0. So now we can solve this really easily. 2s over a all square rooted equals t. Plug in our numbers. 2 times by 30 over 9.8 is our time. Which gives us 2.5 seconds. In part B, how far does it travel horizontally? So now, what do we know? We know the speed horizontally is 8 meters per second. We know the time that it's falling for is 2.5 seconds. Now, you could use the unrounded version. You could use this in your calculation. That would obviously be fine, but I'm going to use the rounded version. And actually, we don't need to know anything else, okay? Because after 2.5 seconds, this object has reached the ground. So it stops traveling horizontally. And in the time that it is falling, it is traveling at a constant speed horizontally. So all we need to use is these two. We need to say that obviously speed is distance over time. So I'm using my SUVAT symbols here. And its displacement horizontally, so this is important, horizontally, is u times time, which is going to be 8 times by 2.5, which is 20 meters. So this distance here is 20. What velocity does it hit the ground with? So now this is a little bit harder. So what we need to do is we need to draw a diagram. So we know, well, actually, we don't know what velocity it hits the ground with, do we? So we need to firstly work out its vertical velocity. So we've got S, U, V, A, and T. So we can use any of the equations because we're trying to find this. So the simplest one is V is U plus AT. So 0 plus 9.8 times by time, which is 2.5 seconds. So its vertical velocity when it hits the ground is 2.5 times by 9.8, which is 24.5 meters per second. And its horizontal velocity is 8 meters per second. So we've got a vertical velocity of 24.5 and a horizontal velocity of 8 meters per second. So what's its overall velocity? Some of you might have done this, but that's not the answer, because which way is it traveling when it gets here? It's traveling in this direction. So we need to make sure we draw out our triangle in this way here. Now, how do we find the missing edge? Super easy. We use Pythagoras. So let's quickly type in our variables. 25 squared plus 8 squared, square root of that. Our velocity is 26.2 meters per second. And what is this angle? Because a velocity needs an angle and a magnitude. Well, it's obviously going to be tan to the minus 1 of 25 over 8. Which is at an angle of 72.3 degrees. And that makes sense because actually this is far, far bigger, so it's going to be going mainly down compared to going across. Question 2 is here. Pause the video now and try this question. As usual, a quick sketch of the diagram will help. So we've got our dart, which is traveling at some velocity u, and it's going to hit a dartboard that is 1.8 meters away. And we know that as it travels, it falls a vertical distance 0.15 meters. Calculate the time of flight of the dart. So this is a little bit like this problem here. We're treating the horizontal and vertical velocities separately. So vertically is how we're going to solve the first part of the problem. Vertically, S is 0.15. U is 0 vertically because there's no initial vertical velocity. V we don't know. A is obviously due to gravity, 9.8 meters per second squared. And T is what we're being asked to find out. So exactly the same as this problem here. S is ut plus half at squared. 0 plus half at squared because u is 0. So our time is the square root of 2s over a. So the square root of 2 times 0.15 over 9.8, which is 0.17 seconds. In part B, what is its horizontal speed? So we've now got a time of 0.17 seconds, and we've got a horizontal distance of 1.8 meters. So what's its velocity? Distance over time. 10.6 meters per second.